Hey everybody. Where are we at in the story of the train? Oh, we got a lot of train stuff. So we've got the hitch magnet. This is the hitch magnet. We've got the hitch peg. We got the wheel. We got the cow catcher. We got the other cow catcher. We got the smokestack. We got the other wheel, and we got the train body. And now they're all invisible. Got three more to make. Let's start with part number 6, the axle peg. Looks like it's easy, but there's actually more going on than you thought when you started here. So we'll start by making a cylinder. You should be pretty cool with doing cylinders by now. The diameter of this cylinder is hard to find because we're looking for like a dimension with a diameter or radius, and we don't get that in the diagram on page 7. But you do see this thread note, and so part of this is learning how to understand and apply a thread note. It says 1/4 20 UNC times 1. Well, looking at that, that first number, 1/4, it stands for the diameter of that screw or that piece of hardware. And so we can feel confident that if we dimension our cylinder with a diameter of 1/4 of an inch, and then extrude it that other dimension that we saw, which was 1.00, that we will get our screw just right. So this is the shaft of our screw. We're going to build the head on the end. That 20 UNC in the thread note means that for every inch, there's 20 threads. Can we thread it right now? I don't know. Let's see. Split face, do, bop, bop, bop. Where do you thread stuff? Still learning about threading in Fusion. So let's put that off for a minute. And there it is. There it is. Under Create, hit thread, hit here. And then we got to put in some thread dimensions. So 1/4 20 UNC. So, you know, that of all the different types of thread notes, that's a fairly ubiquitous one, 1/4 20, 1/4 20. Down at the far end here on the diagram, it says that there's a chamfer with a 45-degree angle and 3/100ths of an inch. So if you remember when we chamfered a bit ago, we can turn on chamfer. 45 degrees is a clue to you that it's equidistant. So this is correct. And we can type in 0.03. And we get an error message? No, it just took a second. And then if we turn it around, we get that nice chamfer, which emulates what really goes on with hardware, so that the hardware can be inserted into the right spots. All right, we're going to build the head on the screw, the axle peg. And so it starts with a sketch on the flat surface and drawing another circle. We're going to go ahead and dimension this circle. The diameter, if you look at the diagram, is a diameter of 0.422. That's an odd number, but go ahead and do that. And then we can go ahead and extrude that the entire thickness or length of 1/8 of an inch. Let's go ahead. We'll grab the inside profile and the outside profile. We're just going to grab it all and extrude everything. 1/8 of an inch, 0.125. So we're going to throw in a nice hexagon, and then we're going to fillet the edge down. We might have to do a rotational cut or fudge it like we did with the hitch peg. All three of those are good options for us. This axle peg is functional, but we can make it a bunch of different ways. So under Create, we've done things like lines and rectangles and splines, but there's also polygon, and we're looking to get a hexagon. So let's go ahead and we'll choose, create a polygon using the center point and a vertex. Let's try that one. So let's try to lock into the center and just draw open a nice hex. And if we can, get it to lock on the horizontal and horizontal plane down here. we'll go ahead and just double check that this is in fact horizontal. So now it is, and we're going to dimension this. It says the hex socket HD is 5/32 across the flats. So from here to here is 5/32, and it's 0.111 deep. So that's how far we got to extrude cut this into the surface. So let's go ahead and dimension it. And that was 5/32. Let's just do that. 5 divided by 32. It expanded just a little bit. And looking at my diagram, I don't think that looks right. I don't think it looks right. So, maybe what we can do is delete this. Just want to delete the dimension. Yep. And maybe let's dimension it acrosswise from here to here. Let's make that 5/32 and see what that looks like. 5 divided by 32. See, that looks like what's going on in the diagram. So I feel more comfortable doing it this way. I'm going to finish the sketch and look at it from an angle. We're going to extrude cut this business in. And the distance that we're cutting it in is 0.111. So it's negative 0.111. Okay. All right, so now all we have to really do is, well, we have to smush down this edge. So if we just put a fillet on here, what's going to happen is it's going to start looking like that, and that's close. Right now it says 0.1. Can we mathematically do this? It's, we could say it's 0.125 minus 0.031. We could try that. Okay, and I got those numbers towards the bottom right center of the diagram. So this is good enough for an axle peg. I'm going to go ahead and make it invisible. We've got, let's do the linkage peg on here, and then we'll save the linkage arm for last. All right, the linkage peg should be a snap. Put a sketch on a plane. We're going to dimension it. This one, the dimensions don't match. So we have to change what we see on here to something else. I'm just going to double check that. But where the linkage peg goes through the linkage arm, our diameter of the linkage peg is 1/16 of an inch. And then the hole it's going through is 1/8 of an inch. So that something's not right there. And then we have to look at the hole in the wheel. And maybe it is just right. Let's take a look at the hole in the wheel. And maybe it's intended to be too small for that one, but just right for the hole in the wheel. I'm trying to find my wheel diagram. Of course, it's the very bottom of the stack of stuff. The hole that it's going into is also okay. So that'll work. That'll work. Let's go. We're going to dimension this shaft part of the linkage peg, and that is very small, super tiny. It's 0.0625, otherwise known as a 1/16 of an inch. Bam. We're going to finish the sketch. We're going to extrude it out. And how far is it supposed to go out? Well, looks like 1/4 of an inch, 0.25. This is very similar to as we did when we were making the other things. I'll put a sketch right on the end there. Let's zoom in. We're going to draw another circle. We can lock in. We'll just draw a bigger circle. And the diameter of that circle is, well, it doesn't really say. It doesn't really say. There's an arc built across the top. Huh. Well, I'm thinking we need to make this one a whole different way if we want to make it accurate to the drawing. Wow. Okay. Let's undo, 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 undo. Back into this sketch. We'll just delete everything in this sketch. So the new way I'm going to try to do this is something like this. I'm going to draw I'm going to draw what I see. And I see something that looks like this, right? If you look at the gray part of your diagram, you get the part that's like cut into the linkage peg. You can see something that looks like this with an arc that connects there to there. So before I put that arc in, I'm going to dimension a few things that I got. The first one is this. It's 0.0625 divided by 2. It's going to make that small. The overall height we get, that's 0.325. So let's go with that. That's 3/8 of an inch. The other side here, it gives us that value as well. That is 0.25. And now we need to put this funky arc on here. So let's go ahead and find arc. And what kind of arc should we draw? Let's draw a center point arc. No. Let's draw a 3-point arc, and we'll just come up here like this, and we'll come out, and we'll just make some funky arc. Now we're going to dimension the arc, and the arc, according to the diagram, has got a standard radius of 0.1562. 0.1562. That's wrong. 562. And okay. It shrunk things a little bit. I don't know why it made this over here smaller. Can we drag this longer? Yes, we can. So let's drag this a ways out. And let's just drag this down. It's not letting me just, oh, there we go. There we go. It's going to, oh yeah, we're going to pull it and then we're going to extend it. Does that look like that? Kind of. Can we pull it up at all? No. Can we pull it out? I think there. All right. Let's go with that. What we don't want is for it to come down into there. So if we get it to come about there, we won't get a little divot in the top of our hardware. It'll look like a nice dome. Now that we're here, we can take this segment and this segment and just trim them out. The trim tool is like the greatest thing ever, folks. If you've never trimmed, this thing deletes line segments that stick out. You can use the trim tool all the time. It's most excellent. Now that we have this shape, we're going to revolve it 360 degrees. There's our axle. And at the very bottom, it says optional chamfer bottom edge, 1/100th of an inch. Let's go ahead and do that. Let's throw a chamfer on this bottom edge, 0.01. That's cute. That is cute. Let's end this video, and we will come back with the final